Welcome back to RS Academy. This is Ravi Shankar Chemistry. In this session, we are going to discuss Lewis dot structure or electron dot structures. So, Lewis dot structures or electron dot structures are very important to show the formation of ionic bond, to show the formation of covalent bonds. Not only that, Lewis dot structures or electron dot structures help us to know what is the valency electrons and valency of the particular element. Get ready, students. In this video, we are going to discuss or we are going to have a talk regarding to Lewis dot structures or electron dot structures. Put it in. Lewis dot structures, Lewis dot structures or electron dot structures. Electron dot structures. So before going on, discuss what is meant by Lewis dot structure. So let us have a talk. How will you get these? How will you these compounds are named as, these structures are named as electron dot structure. So named as Lewis dot structures. So Lewis dot structures or electron dot structures. So these structures are called Lewis dot structures because these structures are introduced by G.N. Lewis. G.N. Lewis. So that's why these structures are called as Lewis dot structure. And why should we call these structures as electron dot structures? Because of, while writing or drawing these structures, we should use electron in the form of dot or in the form of dot or cross. So that's why these structures are called as electron dot structures. These structures are called Lewis dot structure because of these structures are introduced by G.N. Lewis. These structures also called electron dot structures because of, in these structures electrons are represented in the form of dot. So that's why these are called electron dot structures. Are you getting? Right. Now, what is meant by Lewis dot structure or what is meant by electron dot structure? Please make a note. The representation of the representation of the representation of the representation of valency electrons the representation of valency electrons around the symbol of an element, around the symbol of an element in the form of dot or cross, called Lewis dot structure or electron dot structure. So Lewis dot structure or electron dot structure means the representation of valency electrons in the form of dot or cross around the symbol of an element is called Lewis dot structure or electron dot structure. What is meant by valency electrons? I said in previous video. So valency electrons means the electrons present in outermost shell of an atom. The number of electrons present in valency shell of an atom. The number of electrons present in ultimate shell of an atom, called valency electrons. Right. To write Lewis dot structures, we have to know 3 points. That is, atomic number you have to know, electronic configuration we have to know. The third one will be valency electrons we have to know. Please make a note. So what kind of points we require to write electronic Lewis dot structure? 3 points. Point number 1, you have to know atomic number. So if you want to write Lewis dot structure of any element, you must have know atomic number of that particular element. Second point, electronic configuration. Electronic configuration. Electronic configuration. Third point, valency electrons you have to know. Valency electrons. These are the required points to write electronic Lewis dot structure of any element. Okay, right. Next point. We have to remember two rules while writing Lewis dot structures. To write Lewis dot structures, to draw the Lewis dot structure, we require 3 points. Point number 1, atomic number. Point number 2, electronic configuration. Point number 3, valency electrons. At the same time, we should follow two rules while writing writing Lewis dot structure or electron dot structure. Two rules, that is rule number 1, if the element has, please make a note of it, if the element has valency electrons 4 or less than 4, they must be represented as unpaired electrons. They must be represented as unpaired electrons. Please try to understand this rule, that is, if the element has 4 or less than 4 valence electrons, these electrons must be represented in the form of unpaired electrons. Unpaired electron means separately. Unpaired electrons. Point number 2. Sorry, that is rule number 2. Rule number 2. If the element has valency electrons more than 4, then we need to find out paid and unpaid electrons. This is rule number 2. Rule number 1. If the element has valence electrons 4 or less than 4, no need to worry about that. Just we need to represent them as unpaired electrons. Rule number 2. If the element has valence electrons more than 4, in that case, we need to draw the box representation and we need to identify how many pair of electrons are there, how many unpaired electrons are there. After that only we need to represent the electrons around the symbol of an element. So 3 points we need to remember and 2 rules we should follow while writing Lewis dot structure or electron dot structure of any element. Now let us write Lewis dot structure of 1 to 20 elements. Write down one by one. The first element will be hydrogen, atomic number 1, electronic configuration 1s1. How many shells are there? Only one shell with 1 electron. If the element has valence electron 4 or less than 4, they must be represented as unpaired. That's the Lewis dot structure of hydrogen is H dot. This is a Lewis dot structure of hydrogen. Next one, Lewis dot structure of helium. Electronic configuration 1s2. Helium is a noble gas. Is it represented as a unpaired or paid? That's not a problem. So according to given rule, so you should write Lewis dot structure like this, or like this. That's not a problem. This is the Lewis dot structure of helium. Next one, Lewis dot structure of lithium. Lithium atomic number 3, electronic configuration 1s2, 2s1. In this one, this is the first shell and this will be considered as second shell. How many electrons are there here? Only one. So the Lewis dot structure of lithium is Li dot. Li dot. This is a Lewis dot structure of lithium. Li dot. Next one, Lewis dot structure of beryllium. Beryllium atomic number 4. Electronic configuration 1s2, 2s2. Are you following? 1s2, 2s2. The first shell, second shell. How many valence electrons? 2. So beryllium Lewis dot structure is Be 2 unpaired electrons. Unpaired means separately we need to place. The beryllium Lewis dot structure Be with 2 unpaired electrons. Please copy this all. Next one, boron. Boron. Boron atomic number 5. Electronic configuration 1s2, 2s2, 2p1. In this one, this is the first shell. 2s2p considered as second shell. How many electrons in second shell? 3. Boron has 3 valency electrons. So Lewis dot structure means the representation of valence electrons in the form of dot or cross. How many valence electrons are? 3. According to rule number 1, if the element has 4 or less than 4 valence electrons, they must be represented as unpaired. So that is Lewis dot structure of boron will be 3 unpaired electrons. Right? Good. Next one, carbon. Carbon atomic number 6. Electronic configuration 1s2, 2s2, 2p2. First shell, this will be second shell. 4 valence electrons. According to rule number 1, if the element has 4 or less than 4 valence electrons, they must be represented as unpaired electrons. So this is a Lewis dot structure of carbon. Now let us move on to nitrogen. Atomic number 7. Electronic configuration will be 1s2, 2s2, 2p3. Very good. 1s2, 2s2, 2p3. This is the first shell. The second shell. How many valence electrons? 5. If the element has valence electrons more than 4, we need to identify how many pair and how many unpaired electrons are there. Listen carefully. In case of S means S orbital means 1 box, P means 3 boxes, please remember. D means 5 boxes, F means 7 boxes, 1, 2, 3, 4, 5. Remember this. 2S, S means 1 box, P means 3 boxes. Boxes are nothing but orbitals. In S, how many electrons are there? 2, 1, 2. P, 3 electrons, 1, 2, 3. How many pair? 1 pair of electrons, 3 unpaired electrons. So nitrogen Lewis dot structure will be 1 pair and 3 unpaired electrons. Very important. 1 pair and 3 unpaired electrons. Copy these all. Next one, oxygen. Oxygen. Oxygen atomic number 8. Electronic configuration 1s2, 2s2, 2p4. So, how many shells are there? 2, 1 and second shell will be considered as valence shell. How many valence electrons? Yes, 6 valence electrons. We should follow second rule. If the element has valence electrons 4 or more than 4, sorry, 4, that's more than 4. So we need to identify how many paid and unpaid electrons are there. Here 6, that means more than 4. Let us write box representation. S means one box, whereas P means 3 boxes. Valence electrons must be filled like this: 1, 2, 1, 2, 3, and pairing electrons taking place, right? In this one, 2 pair of electrons, 2 unpaired electrons are there. Oxygen Lewis dot structure will be 2 pair of electrons, 2 unpaired. This is the Lewis dot structure of oxygen. Next one, fluorine. Atomic number 9. Electronic configuration 1s2, 2s2, 2p5. Valence electrons. Second shell will be valence electrons with 7 electrons. Let us write box representation. S means one box, P means 3 boxes. Now let us fill the electrons in orbitals. 1, 2, 5, 1, 2, 3, 4 and 5. 3 pair of electrons and 1 unpaired. So fluorine Lewis dot structure will be 3 pair of electrons, 1 unpaired. Next one, neon. Atomic number 10. Electronic configuration will be 1s2, 2s2, 2p6. 8 valence electrons. If the element has more than 4 valence electrons, we need to find out paid and unpaid electrons by box representation. S means one box, P means 3 boxes. So electrons must be filled in this way: 1, 2, 1, 2, 3, 4, 5, 6. 4 pair of electrons. Neon Lewis dot structure will be 4 pair of electrons. 4 pair of electrons. Copy. Right, very good. Next one, sodium. Sodium atomic number 11. Electronic configuration 1s2, 2s2, 2p6, 3s1. How many shells are there? Right, 3 shells are there. First shell, second shell, third shell. Third shell will be valence shell. How many electrons are there? Yes, right, 1. So Lewis dot structure of sodium is 1 dot. That's it. Na dot. The Lewis dot structure of sodium. So no need to write here box representation, because of according to rule number 1, if the element has 4 or less than 4 valence electrons, directly we need to represent them as unpaired electrons. Next, magnesium. So magnesium atomic number 12. Electronic configuration 1s2, 2s2, 2p6, 3s2. First shell, second shell, third shell. The magnesium Lewis dot structure will be, yes, right. You are right. Good. That is two unpaired electrons. Very good. Two unpaired electrons. This is the Lewis dot structure of magnesium. Next one. Aluminium. Atomic number 13. Electronic configuration 1s2, 2s2, 2p6, 3s2, 3p1. So this is the first shell, second shell, third shell. How many valence electrons? 3. Very good. Am I clear to you? Is it clear? Right? Thank you. Aluminium Lewis dot structure. 3 pair of electrons. 3 pair of electrons. This is a Lewis dot structure of aluminum. So no need to enclose with circular boxes, but to give clear picture, I am enclosing in the box or circle. So while writing Lewis dot structure in the exam or notebook, no need to draw these circles. That's not important. Okay, right. Next one, silicon. Silicon Lewis dot structure. Silicon atomic number 14. Electronic configuration 1s2, 2s2, 2p6, 3s2, 3p2. How many valence electrons are there? The first shell, second shell, fourth shell. Sorry, first, second, third. 4 valence electrons are there. So Lewis dot structure of silicon will be 4 unpaired electrons. 4 unpaired electrons. This is the Lewis dot structure of silicon. Next, phosphorus. Phosphorus atomic number 15. Electronic configuration 1s2, 2s2, 2p6, 3s2, 3p3. 5 valency electrons. In case of element has more than 4 valency electrons, we need to write box representation and find out how many paired and unpaired electrons are there. S means 1 box, P means 3 boxes. Electrons S2, 1, 2, P3, 1, 2, 3. Phosphorus Lewis dot structure will be 1 pair of electrons, 3 unpaired. 3 unpaired. Okay, right? I hope you understand how to draw the Lewis dot structure. Is it clear to you? Right. Now, please write yourself sulfur, chlorine, argon, potassium and calcium yourself. If you have any doubt, drop your doubt in a comment box. Right, atomic number I am providing 16, 17, 18, 19, 20. I hope you understand how to draw the Lewis dot structure and how to draw the electron dot structures. Thank you, my dears. Keep on learning, keep smiling. Take care.